Nice. Okay. So hi, everyone. Super happy to have you here despite all the technical issues. Thank you for coming out today. I know this has been a long-awaited SQL workshop. It is a beginner-friendly workshop, so I think that's why there is a lot of audience that has decided to come out today. And in addition to that, I know that SQL is one of the most prominently used tools in the data science industry and data space in general. It's a tool that I use like almost every single day during a lot of my co-ops. And yeah, just about myself really quickly, I'm in my fourth year of management engineering. My name is Ashan. I've done a total of 6 data intensive co-ops, ranging from data analytics to data engineering to data science across like a multitude of industries, from like finance, insurance to big tech and FAANG companies. And so, yeah, without further ado, I guess this is the introduction to SQL Workshop. And yeah, today we'll be exploring how to communicate with databases for analytical use cases. So before we start, if you're not a member, please sign up for updates using this link. I'll post all these links again in the chat if you guys need them. Feel free to check out our Discord community, YouTube channel, and more using this Linktree link. You'll have access to all our different social medias. You'll be able to see our different updates, and you'll just be able to keep in touch with other people that are in this data science community here at U Waterloo. And yeah, feel free to also ask any questions during this workshop or send a message to the Zoom chat at any given time. If you feel that I'm going too fast or rushing over a topic, or if you'd like me to revisit a topic, feel free to ask any questions at any time. And yeah, finally, this workshop will be recorded and uploaded to YouTube. So if you would like to see this again, or if you have to drop out at any time, this recording will be available. So no worries there. Going over the workshop's overview and itinerary for today, we're going to start with what exactly SQL is, what are its various applications, what we can do with SQL, how it's actually used, and then we'll proceed to actual SQL functions. So we'll begin with just selecting data, retrieving information that could be relevant. Then we'll move forward to filtering data, and we'll explore a couple of different commands for that, specifically the where, distinct, and limit clauses. Then we'll move on to group by and aggregate functions for summarizing information. And then we have subqueries and joining tables, so combining different pieces of data together to retrieve more enhanced insights. And we'll be exploring the inner, left, and right joins in specific. And finally, I will leave you guys off with more SQL concepts that you can explore to just be more acquainted with SQL and be more prepared for any interviews if you do have a SQL interview coming up. So in terms of prerequisite knowledge, this workshop is intended to be completely beginner friendly. Some basic coding may help you, such as like knowing conditional logic, when to use and or, because that is common across some other types of programming languages. But other than that, like you don't need too much coding experience. SQL is different from a lot of different coding languages as well, since it is declarative in nature. And it is like very easy to pick up as well, mainly because it's similar to English in the way that it's syntactically written. The one thing that you do need to know is that this arrangement, this structure that you see here, it is a table. If you've used Excel, you should be familiar with this. And this table consists of rows that are horizontal and columns that are vertical. The one other thing that you may need to know is that these four, I guess you can call them column headers, are what you use to actually call different columns, since SQL is indexed based on different columns. So yeah, as long as you know this, you should be ready to start. And you also may need to know that databases are collections of multiple tables. So multiple of these different types of tables would encompass and comprise of a database. So what is SQL? SQL is essentially, what it stands for is a structured query language. It used to stand for structured English query language, and that just goes to show how similar it is to actually English, and how similar it is. Hold on. Okay, how similar it is to English. And yeah, that just means like, again, it's very easy to pick up on and learn. If you know how to read and write in English, it's essentially a language that is used to communicate with and manipulate databases with various applications, which include creating tables / databases, reading information, updating records, and finally deleting records. The acronym for its different functions is commonly referred to as CRUD. So the focus of this workshop, just because SQL is such a large and broad topic encompassing of multiple different concepts, is that we're going to focus on just like the querying and selecting aspect of data for analysis. This is because we are in Waterloo's Data Science Club. Data science is about using data to drive decision making. The other CRUD commands, so create, update, and delete, those operations are more for database administration or data engineering tasks, which you could also explore, but that would not be the focus of today's workshop. You also may realize that once you start interviewing for data science analytics or data engineering roles, they will only ask you to write select queries. I've personally had multiple SQL interviews at a lot of big tech companies like Amazon, Snap, Meta, Robinhood, and Tesla. And they have like entire rounds solely just dedicated to SQL, and all they would ask are select queries. So that's what we're going to be prioritizing today. And I do believe that after this workshop, if you completely and fully understand each of the concepts, you can probably solve a good 1/3 of the questions that these big tech companies do ask you. So I do think like within a 45-minute, 60-minute workshop, that is a pretty good ROI. So yeah, we'll start with the actual commands now. We'll first learn to select data from a table. So this is going to be our first table that we'll start with today. It is the customers table, and it has a couple of different fields, as you can see here: the ID, first name, last name, email, phone number, and preferred contact. So this would be like the input table. And in order to retrieve an output, suppose we want to just retrieve all this information, the command that we would use is called select star from customers. So this would be like the asterisk sign. If you shift 8, you'd be able to get this symbol. Or we can select specific columns. Suppose all this information is not of relevance to us, and we're only interested in like the first name and the preferred contact, because all these last names are different anyways. All the first names are different anyways. We can do that as follows by specifically selecting the column headers that we want to get. So in this case, again, first name and then separated by a comma, preferred contact from customers. So customers is the name of the table, and the from clause precedes the table name as follows right here. If you would like, this customers table is available in SQL Fiddle, and you guys can try it out for yourselves. It's up to you. You don't have to. And this goes for like all the commands throughout the SQL workshop. Feel free to follow along at your own pace and try them out. Again, I will link the SQL Fiddle in the meeting chat if you are not on it already. So the next command that we will learn is the where command. And this is particularly relevant to filtering data and just getting, again, relevant information, but this time in the terms of rows. So the way this syntactically works is that we write the where clause, which is succeeded by a specific condition, and only rows that meet this specific condition end up being selected. Okay, so yeah, as we can see here, this is again the same customers table that we have. And we want to, for example, select names where email is the preferred contact and they do not have a phone number. So the way that would be done is, again, we select the names. So in this case, we want first name and last name. For example, we could just also get first name and we could exclude the last name from the customers table where the preferred contact, so where this field preferred contact is equal to email. So yeah, we want to retrieve all values of email here. So what that would do is that would filter both David Miller and Richard Davis. William Jones will be excluded because their preferred contact is phone, and where the phone number is not null. So if we want to add an additional condition to the where clause, we can do that using and or. And we also want to filter records where the phone number is not null. So in this case, that would be just providing David Miller. Okay, So yeah, the other thing that you may need to know is that there are two, as I mentioned, ways to append where statements or conditions. This can be done using and or the or keyword. So and basically ensures that every single condition in the where clause holds true, and or ensures that either condition holds true. So if this was an or instead of an and, we could make sure that like either condition is satisfied here, basically. So we would also get Richard Davis because his preferred contact is still email, even if this condition is not satisfied. So that's the difference between and or. Okay, so moving on to some other nuances of the where clause. The where clause supports the following math operators. So the equal sign, less than, greater than, less than or equal to, greater than or equal to, or the not equals to. This could be either this symbol or the exclamation mark equals, depending on the SQL provider or relational database management service that you are using. And the other thing that you can do is, suppose you want to select from a range of values, instead of doing greater than or equal to and then less than or equal to in two where statements or with two conditions, what you can do is you can select wherever the column value is between a range of numbers. So between 10 and 20, and this is inclusive. So any values of 10 and any values of 20 will be selected, along with any values between 10 and 20 as well. The other thing you need to know about where is that, suppose you have like a bunch of specific values that you want to select, and there's no way to numerically express them or mathematically relate them using like a range as follows. Suppose like these numbers are interesting to us, like 69, 420, and 1337, but they are not interesting. Like you can't just relate them mathematically. You can use the in command, and then you can wrap all the values that you want to select with round brackets, and then again, comma separate them. So any values with 69, 420, or 1337 will be selected. In terms of other ways to filter information, you can do that by selecting all unique values in a column. So for instance, if you want to only select, like suppose you have multiple records or of a specific name, and you only want to select the unique names, you can do that through the distinct keyword. You just have to place that before the actual column name, and again from before the table name. And if you want to select a limited number of matching records, so if you have like 100 rows, 1,000 rows, 100,000 rows, and you don't want to see all that information, you just want to see a subset or sample of that information, what you can do is use the limit keyword. So in this case, we're selecting all columns from this table where this condition is met, so where ID is greater than 0, and we're limiting by an integer number of records. So if we want to limit and just see like the first 10 records, we would write 10. If we want to limit and just see the first 5 records, we would see 5. And if we want to just see like one record, for example, we could also just do limit 1. So this moves us to our first example that you can try yourself. Feel free to write your answer in the chat. Essentially, this is a new employees table that we're dealing with. It's also available in SQL Fiddle. So try to write SQL that selects the earliest hire date of all employees in department ID number 1 that make under $1,000 salary. And I will also show you how to do this. I'll give you guys like 2 to 3 minutes to try it yourself. If there is one caveat though, I didn't teach one specific command, which you may need to do to specifically get the earliest hire date. But that's what a lot of data science is in the real world. You're not always going to have like all this memorized. You will have to Google a few things. So you may also need to Google something here to get the right answer for this query. But yeah, I'll give you guys 2 minutes to just try it yourself, and then I can show you the answer. If you do have the answer and you're brave enough, do feel free to write that in the chat so others can also see. So yeah, for those of you just joining in, we're starting with our first example here. I will show you how to do it in like 2 minutes, but I'm going to give you guys a chance to try it out in SQL Fiddle, which should be linked in the chat. Okay, we have one answer. You are missing one thing. Look at the condition here in department ID number 1. Yeah, no problem. Okay, I believe it's been 2 minutes. I'll give you guys like 30 more seconds. Yeah, that should be right. Okay, see a couple of answers, so we can take it up now. The first thing you want to do is we're just going to see all the values in the employees table for now. And if we're looking back to our question, what we want to do is select the earliest hire date. And in this case, there's only one field of relevance. So we can start with just the hire date, and we can view all the hire date values. Then we want to add in our conditions. So where department ID is equal to 1 is our first condition. So wherever department ID is 1, those values will get filtered. If we look back, there are 3 rows here with department ID 1. So there are 3 rows that appear. And then our second condition is salary less than 1,000. So we will do that. And yeah, some of you guys did get one of the valid answers, which is to get the first hire date, which is the earliest hire date. So that would be the minimum value. And in that case, yes, we can see the 2005 hire date does get selected. If we want the maximum hire date, we can just do max instead. And then we will get the other hire date. It's executing. Okay, wait, let me refresh. Okay, yeah, so now we get the 2016 value, and there's actually multiple ways to write the same SQL query. So I'm going to show you guys another way. What we can do is use something called order by, which essentially sorts the values that we have here. And in this case, we're going from small to large. So we want to start with the minimum value. So we just write order by hire date. That's the default to go from to go in ascending order essentially. And one thing that I showed you guys, if you remember, is the limit clause, as you can see here. So we could just limit that right now. It should just be sorted in value of a hire date going from 2005 to 2006. And if we limit 1, then we just get the first value. So this is another way to do it. If we want to do the other way around, we want the maximum hire date or the latest hire date, we can just do order by hire date descending. So this is another useful tool to have in your arsenal for sure. Okay, so our next topic will be the group by clause. This is for grouping by rows with the same values into summary rows. So we're again using the employees table here, and we want to select the average salary for employees in each department ID. So you can see here that there's multiple different department IDs, and there's multiple departments with the same ID. Here we want to have a summary of this information by getting the average salary for all values in the same department. So we're kind of like condensing the department IDs to just unique values. That's what group by does. It's like grouping all the rows with 1 into just one singular row. And then we're applying like an aggregation on top of this. So we're selecting the average for this grouping right here. So the way that we write this out in SQL syntax is selecting the department ID, which is the group, and then comma, the salary, which is wrapped around by the average aggregation from employees, which is the table name. And then we're grouping by department ID. One thing that you do need to know is that if you apply a group by, you can do this for just one column. If you're only trying to get unique values, it does the same thing as distinct, but this is actually more efficient by just doing group by. But if you are selecting multiple columns and you have a group by in your condition, SQL will not let you, or in your command, SQL will not let you execute that, because whenever you have a group by, you also need an aggregation, okay? So that's how this works. You can also have an aggregation without a group by. So if you want to just get the average of all salary values and you don't want to apply any groupings regardless of the department, you can do that if you remove department ID. But if you have department ID and then the average salary, again, like you need the grouping by department ID in order to get the average salary per department ID. So yeah, that's one thing that you should know in SQL interviews as well. If you see like some kind of aggregation like average or max or the sum, the total, that kind of thing, then you know that there will be a group by involved. So yeah, as you can see, the result, it will be department ID 1 has this average salary, department ID 2 will have this average salary. So these values essentially condense. Other things that you should know about group by, it's also possible to group by multiple columns. So I use this as an example, which is unrelated to this table. Suppose you want to get the average grade for different study terms for the same course. So for a SQL course in term 2A versus 1B, you can also just group by multiple columns at once to get the average for this combination of columns. So this is another thing that you can know. Other common aggregate functions other than just average are count, which is like the number of rows. So in this case, like we have 3 department IDs, so the value would be 3. The min value, the max value, and the sum of a specific column, that's what we have here. And to show you another example, if we want to select departments with an average employee salary that's less than or equal to 600, this would be a bit different from filtering using where, because we're filtering on an aggregation. So the way to do that is to use the having command, and underneath the group by clause, we would write having and then the aggregation average salary, and then we filter to make sure that this is less than or equal to 600. And yeah, again, our result will filter. So department ID number 1 gets excluded because the average salary is more than 600. So yeah, that's how this would work. Our next topic is subqueries. And what these are essentially inner nested queries or queries within queries. They're used in a lot of different places in SQL. You can use them in a select clause, in a from clause, or a where clause. Typically, in most interviews, I have found that you may need to use them in a where clause. And the way that you can compare subqueries, if the subquery only outputs a single row, then you can compare using any of these mathematical operators that we've discussed already. But if there are multiple rows in the subquery, then you can use either the in keyword or the not in keyword. Either one of these should be applicable. And yeah, essentially like a subquery is just another query. It's the same exact syntax. So you still need the from clause. You still need to select your columns of relevance. You can apply filters, etc. And in this case, we're going to show you an example here. So we want to select all employees that earn less than the highest earning employee. So the first thing we want to do is how are we going to get the salary of the highest earning employee? We want to do just to select max salary from employees. So that's what we have here. We're selecting the maximum salary in the salary column from the employees table. And then that essentially comes out to 1,000. And then from there, we're selecting all these values. So the employee names, the first name, last name, and the salary from the employees table, wherever the salary is less than the maximum salary. So wherever these rows, their values are less than 1,000, that's what will end up getting selected. So yeah, we have like 400, 600, and 500. So that's how subqueries work. We're going to have another example, and this isn't too hard, but it does involve a subquery. The next exercise will be to write SQL that selects the second highest salary. So I've shown you something similar. We've selected second, third, and fourth. Now you need to select just second. So yeah, we'll take another 2 to 3 minutes to try that out. And once you guys have some answers, or once you've made an attempt, I will take it up. And if you guys have any questions, also do feel free to let me know. Like, just type them on the chat. I'd be happy to answer. Can you turn the slide back real quick? Yeah, it's going to be similar to this. So I'll give you 5 seconds and then I'm going to move back to the question. Okay, I'm moving back. Or actually, I'll just type the question in chat and then I'll show you the slide. Because yeah, the syntax for subqueries could be a bit difficult the first time you try writing queries. Yeah, that is one valid way of solving this. There's another way to do it too. Okay, I'll give you guys like 30 more seconds. And then yeah, there is a way to do it without limit, which I will show you guys. I'll give you a hint if you want. The one command that I asked you to search up for the first exercise, the way to do it without limit involves a command that's similar to that. That's the hint I'll give you. Yeah, you got it. Yep, that's how to do it. Okay, nice. So yeah, again, we'll go through this real quick because I think a lot of people got the right answer. So I'll show you how to get the way I like to write my queries involving subqueries is to start with the inner subquery. So yeah, select max salary from employees, would get the maximum salary. And we want to select all values, or yeah, let's just start with this for now. We'll select all the other salaries from employees where the salary is less than this subquery. Let me refresh. Okay, so now we have all the other salaries. There's a couple different ways that I've seen in the chat. They're all valid ways of doing it. You can select the maximum of all of these results to get 600, or you can sort these results. So order by salary in descending order because we want the maximum. And then this will be sorted. Okay, let me refresh again. So this will be sorted. And we just have to limit by just 1 to get the first result here. And that should give us 600. I'm not going to wait for this. Okay, next we have joins. So I'd say like this is honestly the most commonly tested interview clause or a clause during interviews. They are essentially used when databases have multiple tables to separate information and avoid redundancy. And the art of actually like separating information to multiple tables is called normalization, and denormalization would be grouping things into the same table. If you are interested in database design, you can definitely take a look at that. And yeah, so the join clause is essentially used to combine data from more than one table via a common column. So a column that is shared between both tables that you are trying to combine. And this is done using the on keyword. So the on keyword actually relates the columns together. There are 3 different types of joins that do get commonly tested. The first is the most common, which would be the inner join. And this essentially returns all records that have matching values in both tables. So wherever there's a match between the column values, every single row there would get essentially returned. The next type would be a left outer join, and this returns all values in the left table and matching values in the right table. So wherever there isn't a match, all the right table values would just be nulls instead. They would not have any values. The opposite of this would be the right outer join. So this returns all tables in the, or all records in the right table and all matching records in the left table. So it's the opposite of the left outer join. And this can also be represented pictorially using these Venn diagrams here. So table 1, table 2, we want all the shared records via an inner join. We want all the records in the left and matching records from the right. That's when we use a left join. And for a right join, we want all the records on the right-hand side and matching records on the left-hand side, okay? So that's how this works. We'll see a couple more examples. The way to write this out in SQL code would be to select your columns of relevance from the table name. So in this case, we'll just do table 1. We're giving it an alias here. You don't have to, but the alias shortens this so that you can use this like shortened version T1 multiple times within your query. And when you do have joins, that is one thing that makes things easier. So from table 1, T1, we can either do a left or right join onto table 2 with the alias T2. And we're doing this join on the common column that is shared between table 1, T1 and table 2, T2. So we do on T1 dot common column is equal to T2 dot common column. That's how this works. You don't have to write inner and outer. That is something that people do, but for the most part, like a lot of data scientists that I've seen in their SQL code, it doesn't really involve those inner and outers. You could just write join, left join, right join. It still works. SQL code works regardless. And if you would like to join multiple different tables, you could add more join and on statements below this to join those other tables together as well. Other things that you should know about joins, let's just see an example to get this concept down. So we're dealing with the same table as before, the employees table, and also now the departments table. So in the departments table, you can see here that there is an ID. You might have been wondering what the department ID actually related to. Now you can see what that relates to. And you could see that ID number 1 corresponds to HR, 2 corresponds to sales, and 3 corresponds to tech. So what we want to do now is select the total salary of all employees in the HR department. So this employees table, we don't have access to the HR value yet because we only have the department IDs. So we need to join the department ID to the actual department's tables ID. And the way we do that is as follows. So I'll go over the join first because that's what we're focusing on right now. So we want from employees E, which is table 1, and then we're joining on to departments D, which is table 2. And we're doing this on the shared column, which is department ID for employees and the ID column for D. As you can see here, we've made aliases already. So all we need to write is E dot department ID is equal to D dot ID. So that's the shared column. And now we're applying the other things that we need to get. So we want to filter wherever the name is equal to HR, and we want to get the salary. One thing that you should note is that I've used the alias D here for the department name. You don't have to do that because name is technically a unique column here. We only have first name and last name in employees, which is different from this type of name. But suppose in the future, some database developer wants to merge these two columns into just name, and then they rename this, then the SQL query would throw an error. So just to be sure in advance that that doesn't happen, we could write the alias d.name, which is good practice to make sure that we are specifying departments right now. The same thing can be done here. So if we want, we could just make this absurdly clear and write e.salary, and that is technically still a valid SQL query and it's totally fine to do as well. To see what the join looks like, I've actually written out the intermediary result here. So as you can see here, department ID corresponds to ID number 1 corresponds to ID 1 HR. So that just gets attached right here. You can see 1 HR goes there. Again, the same thing happens here, 1 HR, and the same thing would happen here, 1 HR for Jonathan Smith. And finally, for number 2, because that is a different department ID, we would get 2 sales, and that just immediately gets attached here. And this would be the joined table. And then after applying this filter condition and the aggregation, we will get the final output of 1900 as the total salary for the HR department. So I've shown you an inner join example, and now we're going to look into the left join. So in this case, we want to select all departments that don't have any employees. And the way to do that is by using a left join instead. So I've actually switched the order around. I'm doing from departments first and then employees. You could also do employees and then right join. It's the same exact thing. I just think most people, they visualize better left to right. So a lot of people use left join. You don't see right join used as much. And again, we're doing it on the same shared column, which is department ID. And then we're filtering wherever the employee ID is null. Okay, so the way that we could visualize this after the join without any filtering, what ends up happening here is we have the left table, we have 1 HR, all of that's matched to the employees table. We have 2 sales, that's all matched again to the employees table. And we have 3 tech, but we don't find any match within this employees table. So what happens instead is that we have null values populated for every single other column that is technically in the employees table. So all these values are null. And then we're just specifying that the employee ID is null to make sure that we're selecting departments that don't have any employees. And again, to just get the department name, we're doing select d.name. So yeah, the final output in this case would just be tech as expected because there are no employees that are in the tech department. I hope that makes sense. So yeah, we're going to move on to the final exercise of today. We are going to try to write SQL to get the highest employee salary and the total cost of cars that are sold per department. So you can see here, there's a new table that we're introducing, which is the cars table. And this has a field called total cost. So the values of this total cost are right here. And it also has other information like the model of the car, which employee actually sold it, and the customer, but a lot of that's irrelevant information. You just need the total cost. And again, we have the departments and employees fields here. So yeah, try that out. If you want, I could go back to the previous example, but this is going to be a bit different anyways. So yeah, let me know. I'll also type the question in the chat. I'm gonna leave it on this slide for a bit just because this is a new table and we do want to see like the different fields and how they relate to the other tables. So yeah, I'll give you guys like 3 to 4 minutes for this one. And yeah, just to be clear, we're getting the highest employee salary and total cost per each department. So we want like for HR, what's the highest employee salary? What's the total cost of cars sold? For sales, what's the highest employee salary? What's the total cost of cars sold? And like as a bonus, you can try to get tech as well, but it's okay if you can't. I'll show you like with and without tech. I'll also type the join syntax in the chat if anyone needs it. We'll give like 1 more minute. Surprise, no one's gotten it yet. Okay, I will start to take it up now. If someone has an answer. Yeah, I will give you thought process, don't worry. Okay, so first what we want to do is just relay all this information together. So that's like my first thought process. So let's select the fields that are actually relevant to us. So let's get like the highest employee salary total cost. Okay, so I'll select the department name. So that's going to be e dot name. And then we want salary. I'm not going to do any aggregations yet. And we want total cost. And then we want to join all that together. Okay, so actually, before we select the fields we need, I'll just show you what the join looks like by doing a select all. So employees is the first table. I'm going to give it the alias E. And we want to join that with the next table, which is departments. And I'll give that the alias D. We're going to join on this common column, which in this case, it looks like should be department ID. So department ID. And then D has just ID. And we'll join to the next table, which is cars. And it looks like the shared column here is employee ID for cars and employee.id for employees. So e.id is, or sorry, join cars C on e.id is equal to c.employees employee ID. So that should be just the join for now. We're relating all this information together. And one thing that I specified before is that if we want to retrieve the highest of something or like an aggregated version of something, and we want to do like a summary here, so we're doing per department, that's when we use the group by clause. So group by always goes at the end, and we're going to group by, in this case, the department name, because we want to do it per department name. And we'll do a select here. Now, this is not going to work because we don't have the aggregations yet, or it will work, but it's just going to show the first value. And if we want to perform the aggregations, we want to get highest employee salary and the total cost of cars sold per department. So highest salary will be max salary, and then total cost will be the sum, because we want to add everything up together. Now, if we run that, we should get the max salary for HR sales, and then the sum. So the total cost of the cars sold by employees within HR and within sales. So one thing that you might be wondering is, why isn't tech here yet, right? Tech is also another department, but the issue is that when we did the join, there aren't any employees that belong to the tech department. So that row automatically gets filtered out and isn't in the actual like query output or result. So instead, since departments is the table on the right in this case, and we want to retain all the values from the table on the right, we are doing a right join here. And this still won't work because we're doing another join. And in this join to cars, there aren't any employees within like tech, and there's just going to be null values. So we need to also do a left join to ensure that all values from this joined table are still retained. And I believe this should give us tech and then null max salary and null sum total cost. So I think, yeah, that should answer the problem. If there are any questions, let me know. I hope that makes sense. Yeah, left and right joins, they take a while to get used to. The way that I got better at them was just like, again, step by step, seeing the output, visualizing what like different query results would actually like give me. So yeah, just like keep playing around with SQL as you use it more and more, and as you use it over co-ops, that's when you really get good at it. And like right now, I could just like immediately visualize the code that I'm about to write. So you will eventually get to that level. It just takes more and more practice. So yeah, other than that, other SQL concepts for interviews that you guys can learn if you do have an interview upcoming. And these are all concepts that I've been tested on throughout various different interviews. It includes self-join. This is just essentially joining the same table again. So a use case of that, if you want me to show you really quickly, would be just like this employees table and the manager ID. Since they're both in the same table, if we want to see like employees that earn more than their manager, we would join on the same table and then join the manager ID to the employee ID. So that would be like a case there. There's also string functions for processing and formatting different string results. We've mostly just explored like mathematical relationships. So there's also string relationships. There's also the like keyword, which is related to that. There are various date functions for filtering, processing, formatting dates. There are CTEs, which are different ways to write subqueries. So it's essentially a means to like retain one subquery and use it again in multiple different queries. It's very efficient. And I actually prefer to use CTEs more than subqueries in a lot of interviews as well. There are the union and union all commands, which are instead of, I guess, horizontally joining with joins, we vertically stack query results on top of one another. So that's what these commands do. There is the case when command, which if you're familiar with other programming languages is like if statements. And finally, there are window functions, which are typically like the most advanced form of SQL that you will get, but I have gotten this in some SQL interviews as well. So you could learn like over, partition by, lag and lead, rank, dense rank, and row number. They're all commonly tested window functions as well. So in terms of how I learned SQL and got better with SQL, I've kind of condensed it to like the primary resources that help me out. W3 Schools is a very like, I guess, very thorough tutorial, and it goes through like all the different nuances for every single function in SQL. So you can learn literally everything you need to know through this one resource. There's also mode.com, which pretty much separates a bunch of like different SQL questions by topic. The sample DB that we've used today is also linked within this slide. And I think this is a great way for just like trying out different SQL queries, visualizing like intermediary results. What does a join do? What does this subquery do? What happens when I apply a group by? That's when this really comes in handy. And in terms of practicing for SQL interviews, HackerRank is useful because it again segments things by topic and also like kind of shows like different levels of difficulty. So like beginner, intermediary, and advanced. So you can like kind of level up your SQL skills in that sense. Strata Scratch has a lot of SQL questions directly related to what FAANG companies may ask, with like information related to like what they actually would experience at their own companies. So like Facebook data sets would literally have like Facebook profiles as tables, things like that, posts, Facebook posts, etc. Lead code is again like a standard. They now also have database questions. There aren't too many of them, but I do find like the questions that they ask very, very helpful in just like nailing down different SQL concepts. So with that being said, thank you so much for staying until the end, despite all the technical difficulties that we've experienced. If you do have any questions, feel free to let me know in the chat. I'd be happy to take some time to answer them. And if you do have feedback for next time, feel free to fill out this form, positive or negative. It's totally fine to let me know. And this is how the workshops for Waterloo's Data Science Club get better over and over again. So yeah, any feedback that you may have, I've attached the form in the chat. Feel free to fill out this form. Okay, we have a question here. I think another important one is having without filtering aggregate columns with group by. Yeah, that's totally valid too. Having can definitely be used in other contexts as well. So yeah, any final questions, just let me know. That being said, yeah, thank you again for coming out. I hope you have a good rest of your night. Yeah, no problem, guys. Hope this helped. Yeah, I will end the meeting.